In this video, we'll be treating conversion of bases. I'll show you how to convert from one base to another. We're basically going to use these four number base systems: the binary, the octal, the decimal, and the hexadecimal, because this video is targeted towards computer students, and in computer science we only deal with these four number systems. Okay, let's begin. So we're going to start with a binary number. We're going to convert it to its base 8 equivalent and to its base 16 equivalent. So what I'm going to use to convert from base 2 to another base, there are two methods. The first method, we can't directly convert from base 2 to another base. We have to first convert it from base 2 to base 10, and from base 10 to the target base in which you wanted to convert the base 2 number to. And the second method, you can convert from base 2 to the other bases directly. So let's begin. The first method, what we do to this number, for example, we have this base 2 number here, 101101111 in base 2. We first of all give it powers, and we'll start from the right hand side, and we'll start with 0, 0, 1, 2, 3, 4, 5, 6, and 7, like that. So what we do next, this is how we go. We say 1 times, that is, we took this first figure here from the left hand side, times 2 raised to the power of 7, this power that was here, you see that, then plus, then the next number, 0 times 2 raised to the power of 6, plus 1 times 2 raised to the power of 5, plus 1 times 2 raised to the power of 4, plus 0 times 2 raised to the power of 3, plus 1 times 2 raised to the power of 2, plus 1 times 2 raised to the power of 1, plus 1 times 2 raised to the power of 0. Now the next step from here is very easy. You can easily use your calculator to solve this all. You can bracket it and input it directly into your calculator as it is, like this, with a bracket. So I put this so that you know how, in order to solve it easily there. So after solving everything, if you did it correctly, this is what you are going to get: 183 to base 10. You see, 1 times 2 raised to the power of 7 will go 128, 0 times 2 raised to the power of 6 goes 0, 1 times 2 raised to the power of 5, 32, plus 1 times 2 raised to the power of 4, that is 16, plus 0 times 2 raised to the power of 3, that is 0, plus 1 times 2 raised to the power of 2, that is 4, plus 1 times 2 raised to the power of 1, that is 2, plus 1 times 2 raised to the power of 0, that is 1. For some of you that don't know, any number raised to the power of 0 is equals to 1, so that means that is 1 times 1 to give us 1. So that's how we got 283 to base 10. So now let's say our target base in which we wanted to convert this base 2 number to was base 8. The next step now is to do something like this. We'll put our 8 here. I'll put the 183 to base 10. So now if we want to convert it to base 8 or base 16, this is what we'll do. And if we want to still convert this number back to base 2, this is still what we are going to do. So this is what we are doing here. We are going to divide 183 by 8. Then whatever number we get, we'll put down its remainder by the side. If it's remaining 1, remainder 1, or remainder 0, or remainder 3, or we'll put it there till we have the last remainder, till the number can't be divided anymore. So this is how it goes: 183 divided by 8, we have 22. 22 times 8 is what? I'm showing you guys how to get the remainder. 22 times 8 is 176. So 183 minus 176 is equal to 7. So that is remainder 7. Then we go again. 22 divided by 8 is what? to go 2 times. 2 times 8 is what? 16. So 22 minus 16, what do we have? We have 6. So that is remainder 6. And we can still go again. And 2 divided by 8, it can't go. So 8 can't go into 2. So we'll put down 0. Remainder 2. So now we'll take the number from the last figure here. That is 267 in base 8. Very simple. And if we are doing it to base 16, we'll do the same thing exactly, and to base 2 we'll do the same thing exactly. Very simple. So going to the next method, that method now we can easily convert this number in base 2 directly to base 8 or base 16. And here's how it goes. So we have 1 0 1 1 0 1 1 1, and now we want to convert this base 2 number to base 8. This is how it will be. From the right hand side, we are going to count in threes. 1 2 3, 1 2 3. This 1 2, since it has to be 3, we can just add a 0 here. Now you might not understand what I'm doing here, but you see, as it's in base 8, when we want to convert this number to base 8 using this method, we are going to group them in 3 bits. And if we are converting the number to base 16, then it will be grouped in 4 bits. That is like this: 1 0 1 1 0 1 1 1, and it will be 1 2 3 4 1 2 3 4, 4 bits. So now that it is to base 8, we'll group it in 3 bits. This last one only had 2 bits, so we added a 0 to make it 3 bits. You always add a 0 when it has an incomplete bit. So if it was 1 that was the last bit, there was 0 0, and so on. So to continue, each of these bits now, they will have their own powers, and these powers are in a geometric progression. Goes like this. So first we have 0 1 0. So this side to be, starting from the right hand side, we have 1. So 1 times 2 is what? 2, and 2 times 2 is 4. So that is it. 1 4 2 1. So each of them 4 2 1 4 2 1. So we have 0 1 0, have 1 1 0, have 1 1 1. Each of them have a power 4 2 1 4 2 1. And if we are converting this number, we are converting it to base 16, as it is in 4 bits. This is how it will go. We have 1 times 2 is 2, 2 times 2 4, 4 times 2 8. So each of them will be 8 4 2 1, 8 4 2 1. So back to this one. So we are converting it to base 8. This is how it will be. So 4 times 0 is what? 0. 2 times 1 is what? 2. 1 times 0 is what? 0. Very easy, right? And we have here 4 times 1. That's just how you do it. 4 times 1, 4, plus 2 times 1, 2, plus 1 times 0 is 0. Simple. And here we have 4 times 1 is what? 4. 2 times 1 is what? 2. And 1 times 1 is what? 1. So adding everything up, we have 0 plus 2 plus 0, we have 2. Here we have 4 plus 2 plus 0, that is 6. And here we have 4 plus 2 plus 1, we have 7. So converting this number in base 2 to base 8, we have 267 in base 8. Very easy, right? And look at it. Using the first method, this is what we got. And using this second method, you see, to show that we're on the right track. And now if we want to convert it to base 16, how I told you, in 4 bits, 8 4 2 1. This is how it will be. Starting with these ones, 1 0 1 1. So this is 8 4 2 1. And we'll have 0 1 1 1. The next 4 bits, I'll have 8 4 2 1. The same thing applies. 1 times 8 is what? 8, plus 0 times 4 is what? 0, plus 1 times 2 is what? 2, plus what? 1 times 1 is what? 1. And here we have 0 times 8 is what? 0, plus 1 times 4 is what? 4, plus 1 times 2 is what? 2, plus 1 times 1 is 1. This one, yeah, like what I'm doing, I'm multiplying them with the powers. If I do not make myself clear in this one, we're multiplying the individual number by the power that is on top each of them. So now what do we have next? Just like how we did here, we'll add it. 8 plus 0 plus 2 plus 1, that is what? That is 11. And here we have 0 plus 4 is 4, 4 plus 2 plus 1, that is 7. So you have, and note that from here, you saw what I did, right? Hexadecimal base 16 will have 0 to 9, A to F, because this is how it is. We'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 in the hexadecimal number system is represented as A, and 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. F. So now we have an 11 here, so that means we are going to use what? B. So your answer is B7 in base 16. Very easy. So now the next thing I'm going to treat is how to convert from a decimal to binary in a very easy manner. I've showed you guys how to convert from decimal to binary and to the hexadecimal and octal using this method, the division and remainder method. So the next method now is from the decimal to the binary, another method again. Sorry for my jumbled up English. Okay, this is how it goes. First of all, we're going to write down the geometric progressive powers that I did here. And we're going to start with 1, remember, and we're multiplying it by 2. So that is 1 times 2 is what? Is 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. So what we are doing here, we want to convert this 183 that we know back, 183 in base 10 back to its binary equivalent. And why I stop this geometric progressive on my English, okay, why I stopped here at 128, when we do 128 times 2, we're going to get 256, and 256 is more than 183, so we can't use it. It's part of the rules of using the method. The number in usage, that the number we want to convert is supposed to be more than the last power there, or equal to the power. So let's continue. So this is what we are going to do next. You can find 128 in 183, or should I say 183 can be divided by 128, because it is smaller, even though it will give a remainder and the rest. So what we are going to do, we are going to put a 1 here, signifying that 183 contains 128. So after doing that, we are going to say 183 minus 128, and 183 minus 128 is equals to 55. You can see that. Sorry for the messed up work. So we have 55. Does 55 contain 64? No, 64 is greater than 55. So what are we going to do? We are going to put down a 0. So we see shift the 55 to 32. Does 55 contain 32? Yes. So we'll put down a 1. You see that? So since you have put down a 1, you are going to say 55 minus 32. And you have what? 23. Can you find 16 in 23? Yes. So you put down a 1 and you see say 23 minus 16. And 23 minus 16. 23 minus 16. It gives you 7. Can you find 8 in 7? No, 8 is greater than 7, so you put down a 0 and you bring it here. So can you find 4 in 7? Yes, you put down a 1. 7 minus 4 is 3. Can you find 2 in 3? Yes, so you put down a 1. 3 minus 2 is 1. Can you find 1 in 1? Yes, they are equivalent, so you put down a 1. And what do we have here? 1 0 1 1 0 1 1 1. And that was our original number. 1 0 1 1 0 1 1 1. Very cool, right? Very easy. So in our we are going to do another video next time, and it is going to show you how to convert the number bases that have that have fractional parts. Example, you have 23.4 in base 10, 1011.011 base 2, and so on and so forth. And those ones are very easy. She's going to show you the methods of doing it. So thank you for watching our video. I hope you like and comment, and you share the video, and I hope that you subscribe to our YouTube channel. This is my first time of doing this, even though I'm stuttering and the rest. I hope that you enjoy the class, and I hope you understand. If you don't, please leave your complaints in the comment section, and I'll work on the problem next time. Thank you for your time.